So hello everyone, welcome back to the channel, and this will be a short lecture on projectile motion. We will cover everything from theory to just an example of like an example problem of this chapter. So let's get straight into it. To start with, let us first define what is a projectile. So whenever we throw a ball like a cricket shot or launch a rocket, or you can think of javelin throw or anything like that, when you throw an object, like whether it is a cricket ball or a javelin or a hammer in hammer throw, discus, anything, so the object follows a curved path. So this motion under gravity is basically called a projectile. So, and if we say formally, then a projectile is an object projected into the air with some initial velocity, and thereafter it moves only under the influence of gravity. So that is the formal definition of a projectile. And in this lecture, we will have some assumptions while we derive the necessary relationships and all. The first one will be that we will assume that there is no air resistance, so which is not the case really, but for our calculations we will for now assume that there is no air resistance. Later we can introduce that if we have time, and after that we will also have another assumption that acceleration is only due to gravity, and the acceleration that g that is downward and that is constant. Okay, so as we already gave an example, you can think of a cricket ball or throwing any ball, any object, any like stone as projectile. So okay, so let's get straight into the mathematical analysis of projectile. So suppose this black object here, right here, this is its initial position. We are throwing this from here, and suppose that this is thrown with an initial velocity u, and this velocity u makes an angle of theta with the x-axis. So this angle is theta. Okay, so we can write that we can break this velocity into x and y. So this is just ux will be u cos theta, and uy will be u sin theta. Okay, so yeah, and about the accelerations in x direction, as we have already assumed that there is no air drag or any force, so the acceleration is in x direction is basically 0, and the acceleration in y direction, that is nothing but minus g. The minus sign comes because the direction is downward, so that's it. Okay, so let us now basically write the equations for the kinematic equations. So first, for the horizontal motion, we can just write that x equal to, that is nothing but ux into t, because in u, this is a constant velocity ux, as there is no acceleration, and in t time it will just cover ux into t path, so, and va horizontally. So that is it. And we can also write the same thing for the y part, which will be nothing but y is equal to uy into t, and here actually we have an acceleration which is downward. So you can think it as of a is equal to ut minus half at square. So here a is basically minus g, so that is nothing but minus half gt square. Okay, so we have got this y, and now we can just differentiate these both to get the instantaneous velocities. So vx will be nothing but your ux, this doesn't change. Let me just remove this mark here. Okay, so vx will be nothing but your ux, this is constant, and this vy, this will be nothing but your uy minus gt. Okay, so this is just the derivatives of the, I hope you know that vx equal to dx dt and y is equal to vy equal to dy dt. So okay, so now let's get straight into calculation of the time of flight. So we know that at landing y is equal to 0. Okay, at let's denote the time of flight by t, capital T. So at landing y is equal to 0, at t is equal to capital T. So that is it. And for this, so we can just write that t into uy minus gt by 2, this is equal to 0. Now t is not equal to 0, therefore we can, we directly get that t is equal to 2uy divided by g, or we can also write that 2u sine theta, as uy is nothing but 2u sine theta. So this is our time of flight of a projectile. So this just means that when we throw a projectile and it follows our assumed things, like there is no air drag and those things, so after that we get this relationship for the time of flight. So it will land at the ground at after this time, from starting from t equal to 0 to t is equal to capital T. So okay, after this there are 2-3 more things. After this we just have the maximum height, and at the maximum height, if you look into it, suppose that this is the maximum height, this point. At this point, till this point, the particle rises, and after this the particle starts dropping. So at this point, the vertical component of the velocity must have been 0, because it was upward till this point, and suddenly it becomes downward. So it must have been 0 at the topmost point. Okay, so let's model it that way. So uy equal to 0 at y is equal to h. We are basically denoting the highest point by capital H. So therefore we can just write that h is equal to, this is minus half. So it will be easier if we use another equation of kinematics, which is your that v square equal to u square plus 2as. So using that you can just write vy square, which is the instantaneous velocity, is equal to uy square minus 2g into h. So we already said that this v is 0, this will be v, so this is 0 at the highest point. Therefore we can just write 2gh is equal to uy square, which will ever give that h is nothing but your uy square divided by 2g, and you can again write it as like uy square sine, this is u square only, u square sine square theta divided by 2g. So this completes another part. So after that we have the horizontal range of a projectile. Okay, so horizontal range is basically the distance the projectile covers in its time of flight. For example, you can think of the suppose a batsman in a game of cricket hits a 6, then the ball lands somewhere, and suddenly you have a 6 distance, like in the television they show you the distance of the 6. So that is the horizontal range basically. So we can just we can very simply derive it. So let's denote it by r, and r is nothing but ux into what it travels in the total time of flight. Okay, so this is ux into t. So therefore we already had t is equal to your uy by g. Therefore very simply we can get that r equal to your 2 into ux uy divided by g, and if you simplify that, ux is equal to u cos theta and uy is equal to u sin theta, so that is u square, and we have a 2 here, and sine 2 into sin theta cos theta becomes sin 2 theta. So this is nothing but u square sin 2 theta divided by g. So okay, so we have derived the time period, the maximum height, and the range of a projectile. So the next thing that comes into the picture is the trajectory of a projectile. Okay, and also before that, you can just see that the maximum range of the projectile, that can be u square by g, because the maximum value of sine 2 theta, any sin x, for any x, the maximum value of sin x is 1. So sine 2 theta is maximum value is 1. So therefore we can just write that r max is equal to u square by g, and that happens when theta is equal to pi by 4, or you can write 45 degrees, because 2 into 45, that is 90 degrees, and sin 90 degrees is 1. So that gives us the maximum range. And okay, so let's now derive the last thing, I mean the last theory, which is the equation of trajectory. So for the equation of trajectory, we can just write that, start with this velocity in x direction. So this is x equal uxt. Therefore we can just write t is equal to no, it's x by ux actually, t equal to x by ux. Okay, so we have got a value of t here. So now let's just write this value of t in the equation of y. So we had y is equal to uy t minus half gt squared. Let's just substitute it here. Okay, so uy into x by ux minus half into x by ux and this whole square. Okay, so now this uy by ux, we can just write uy by ux into x, and this is as it is, gx square by ux square. So yeah, this is basically, now this uy is u sin theta and ux is u cos theta, so u cancels out, and we have sin theta by cos theta, which is our nothing but our tan theta. So this is nothing but x into tan theta, and here if we substitute u, so this becomes gx square, which is in the numerator, and here we have 2u square and cos square theta, as ux equal to like u cos theta. So actually this is our final relation for the trajectory. So you can just write y is equal to x tan theta minus gx square 2 into cos square theta. So these are the main 4 theoretical things in a projectile motion. This is the this was the equation of trajectory, and except that your let me just summarize the whole thing in a very short time. So we first derived the time period, which was your which came out to be this uy by g, this thing, and after that we derived the maximum height, which came out to by like uy square by 2g. And by the way, an interesting thing is that this maximum height, like it will be maximum at theta is equal to 90 degree. Okay, so which makes sense, because theta equal to 90 degree is the case when you throw the projectile like right this, so all the velocity is upward. So this I mean this indicates the case of the maximum height, so that is this vertical throwing up. So that makes sense anyway. And again we had r is equal to this u square sin 2 theta by g, and once again that this is maximum at theta equal to 45 degree, because we are having a sin 2 theta here, which is sin 90 degree. and the maximum value is you can see that u square by g. And after that we derived the equation of a trajectory of a projectile. So there can be a sample question, like let us look into a problem. For example, like take some y is equal to x minus gx square divided by 4u square. Okay, no, not 4u square. Let me just take gx divided by let's take 16u square. Only 16, I'm very sorry. So okay, so let's say that this is the equation of a projectile, and you are tasked to find the maximum height of this projectile. Okay, so how do you do that? So first of all, you can see from the equation of trajectory, y is equal to x tan theta, which directly gives you theta equal to 45 degree. Okay, and in the denominator of this gx square, you have 2u square cos square theta. Okay, so and from comparison this and this, so this is nothing but equal to 16. So okay, and you had theta is equal to 45 degree, so u square cos square 45 degree, that is equals to your 8, because 2 and 16 cancels out. Okay, so that is equal to 8, and this cos square 45 degree, that is half, because cos 45 degree is your 1 by root 2, so this is u square by 2, and this is equal to 8, so you get that u squared is equal to 16, and therefore we are taking only the positive value, because the magnitude of velocity, that is positive. So this is 4 meter per second square. So problems like this are pretty common in any exams, you can say. So kind of that was all of it from the lecture. I hope you got an idea of what a projectile motion, I would say that what a 2D motion actually is, and what can be asked from these topics. So yeah, that's all, and I hope you enjoyed the lecture, and we'll see you in another video.